Hey everyone, it's Rygo here from Rygo Tech. Welcome to my guide for buying a laptop or desktop computer. So I want to go through the things so this is basically for people that are not really technology minded. They don't know what things to look for when they're buying a laptop or desktop computer. So for those of you that already have an idea of what to do, then this guide is probably stuff that you already know. But for the rest of you, if you want a good idea as to what things to look for when you go out to buy a laptop or a desktop computer, then carry on watching. The first thing we need to do in part one of the series is to learn about the different parts of the hardware of the computer, because if you have an idea about what all the hardware is inside your laptop or desktop computer, then you'll know what things to look for. Right, so the first major piece of hardware in your computer is the motherboard. So here's a picture of a motherboard here, and the motherboard is the thing that connects all the different components of your computer laptop together, and it communicates with all the different parts on here. So you see a whole bunch of little chips and things. These are all soldered into the motherboard here, and they will all communicate with each other. Now, when you're buying a pre-built laptop or desktop computer, generally you don't need to worry about the motherboard because it's already there. It will be a reasonably good one anyway, and you're not going to be able to change it unless you specifically looking for a specific type of motherboard. So generally you don't need to worry about too much what the motherboard is. If you're building your own computer, however, then that's a different story. But then again, you'll know everything you need to know anyway, so that you don't need to watch this beginner's guide series. So anyway, I just thought I'd mention that. So when you hear the term motherboard, that's what it means. It's the board that contains all the different components of your computer, and it allows all these components to communicate with each other. And you'll see on the edges we have the different things like the USB ports, the HDMI ports, which connect to TV screens and that kind of stuff. And you'll see little chips on here which do all the various functions of your computer. Alright, so that's what the motherboard is. But again, when you're buying a pre-built laptop or desktop computer, you don't really need to worry too much about the motherboard. So the next major thing you really need to worry about or think about is the central processor unit, or the CPU. Alright, so generally there are three big players in the CPU market, which most people end up kind of buying. We have the CPUs from AMD, or Advanced Micro Devices. So their latest chips are called the Ryzen chips. We have CPUs from Intel, who you've probably heard of. Really huge company, obviously, supply a lot of CPU chips for laptops and desktop computers. And more recently, Apple have started producing their own CPUs, starting off with the Apple M1 CPU. So what is the central processor unit? Well, basically it is the brain of your computer. So for your computer to perform any tasks, it's all done inside the CPU generally. Okay, so all the main things are done inside the CPU. So back in the early days, you had one CPU inside your computer, and the CPU could only process one instruction or one task at a time. And so obviously if you had lots of tasks to perform, it could only do one at a time, and so it took quite a bit of time to work through those things. Now CPUs actually will execute those tasks really fast, because we're getting faster and faster every year. But back in the old days, it could only do one thing at a time. So after that, the engineers came up with a way of being able to have CPUs to multitask. So I don't know if you've ever heard that term before, CPU multitasking. So it's just like us, where we can do two things at the same time. But in actuality, we never do two things exactly at the same time. What we do is we do a little bit of one thing, and then we do a little bit of the next thing, and then we do a little bit of the other thing, and then we do a little bit of the next thing. And so we swap backwards and forwards between the two things, doing a little bit of each. And if we do it fast enough, it looks like we're doing both things at exactly the same time. So that's what CPU multitasking is. So your CPU will do one part of one task first, and do a part of the next task. Then go back and do a part of the first task, and then go and do a part of the next task. And it keeps doing that, and because it does it so fast, it looks as if it's doing both of those two tasks at the same time. So that was the next step in the evolvement of CPUs. and it allowed us to start to do more interesting things. These days, our modern CPUs have what are called multiple cores and multiple threads. So let me talk about what these are. So multiple cores you can think of as tiny little brains inside the big brain, which is your CPU. Okay, so a chip might have 8 cores, so that means inside the big chip it's got 8 little cores inside it, which are 8 little CPUs, and they can talk to each other and they can access all the resources on the CPU chip. And so in effect, the big CPU could do 8 things at one time because it has 8 separate cores inside that particular CPU. So you could have 2 cores, 4 cores, 8 cores, 16 cores, 24 cores, and so on. So it normally goes up in steps of 2 because that's how they kind of package things up inside the CPU. So the more cores you have, the more things you can do at the same time, right? So if you've got 4 cores, you can do 4 things at once. If you have 8 cores, you can do 8 things at once. Now, it does mean that the software that you're running has to be able to take advantage of these extra cores. So things like gaming aren't really made for multiple cores. They generally just run on a single core. So you want to have a CPU which is a very fast single core speed. Whereas other applications like image processing applications, video editing applications, using Microsoft Word, all of those things are built to take into account your CPU having multiple cores. And so yes, you will get a big advantage for having multiple cores when you use productivity type software. So that's what multiple cores are. So you just think of multiple cores as little brains inside your big CPU, and each little brain can do a task at the same time as the other little brains. So the other term you'll probably come across is called multiple threads. So what is multiple threads? Well, basically a core we can get to do what I talked about before about multitasking. Do a little bit of one thing and do a little bit of the next thing and then go back, do a little bit of the one thing. So that's what threads are. So a core can have 2 threads, which basically it alternates between doing each thread a little bit at a time. So basically, because it does it so fast, it looks like it's actually doing double the number of core work. So if you've got 8 cores and you have 16 threads, it looks like you're doing 16 things at once, but in effect you're still only doing 8 things at once, but it's just doing it really fast, and so it looks like we're doing 16 things at once. So that's what threads are. So threads aren't particularly as good as cores, because cores is a separate unit, whereas a thread runs on top of a single core or unit and it alternates between executing the particular threads. So having more cores and more threads is useful, but more cores is the better metric that you want to do. So the CPU speed determines how fast work gets done on your computer. So basically in your CPU there's a little clock which ticks a certain number of times per second, and when the CPU clock ticks, it tells the CPU to perform its current set of operations and then wait to move on to the next one, and then the next time it ticks, it then does the next set of operations. So the faster your CPU clock ticks, the more per second, the more operations will get done per second. Alright, so these days a very basic CPU will be around 1 gigahertz, and 1 gigahertz is actually 1 billion hertz or 1 billion ticks per second. Okay, so 1 gigahertz is 1 billion ticks per second, so per second it can do 1 billion operations. It's not exactly how it works, but that's how we can generalize it. Alright, so if you've got a CPU which is 4 gigahertz, then it can do 4 billion ticks per second, or 4 billion tasks per second. So the higher the gigahertz rating, the higher your speed is, and so the more tasks it can actually get done. Now it's not the fully determining factor of how fast the computer is, because it also takes into account all the other components of your computer as well, but it's a good general rule to know how fast your computer will be. Alright, so when we want to buy a computer, we want to look at the CPU speed and what type of CPU it is, whether it's an AMD one or an Intel one or an Apple one. So Apple, you can only buy the Apple chips and the Apple computers, so that's not a problem. If you're buying a Windows computer, then you'll need to pick between a Ryzen and an Intel CPU. But we'll talk about that in the second part of this particular guide. Alright, so that's what the central processor is, what a core is, and what a thread is, and what the CPU speed is. So let's go on to the next thing. So the next thing is random access memory, short for RAM. Okay, so RAM, as you can see in the picture here, are little chips that are put onto a little motherboard, and then this little RAM motherboard is plugged into your big computer motherboard, and so your computer can now access the data on these little RAM chips that are on this these little chips inside this big RAM chip here. So it's called random access memory because your computer can randomly access any data on any of the little RAM chips that are on there. All right, so you can access them directly and randomly, so it's extremely fast to access all of that. So what is RAM chips used for? So the RAM chips are used to hold data and programs when your computer is running. So when you turn on your computer, it starts to load Windows, or it starts to load the Apple operating system. So all of those programs that your operating system needs to run is loaded into your RAM. So once it's finished loading, before you can start to use your applications, so whatever RAM is left after the operating system is loaded. So the next thing is random access memory, short for RAM. And a RAM chip contains little tiny chips in here called memory chips, and they make up the big RAM chip here. Okay, and this big RAM chip is then plugged into your computer motherboard, and the computer can access the data on these little RAM chips directly. So what is random access memory used for? So RAM is used to hold data and programs when your computer is running. So when you turn your computer on and it loads up your Apple operating system, or it loads up Windows 10 or whatever version of Windows you have, it has to load all of the data and all of the programs for your operating system into your RAM for it to then be able to run your other applications on. So your operating system will take up quite a bit of that RAM, and then whatever's left you can then use for running your programs. So if you start up Microsoft Paint or you start up Microsoft Word, then it has to load that program into the computer's RAM and also load its data into the RAM as well. So that gets used. So the more RAM you have, the more programs you can run at the same time, and the more data you can actually load. Okay, so so at the moment I've got Google Chrome running here. I've also got Firefox running down the bottom. I've also got OBS Studio, which is recording my screen to create this particular video. So I can only load all these programs if I have enough RAM in the computer for me to be able to load that stuff up. If there's no RAM left, you won't be able to open up an application. Now Windows does have a way of getting around this problem, and it will, what it does is it saves things out to another storage part of your computer so that you can load a new thing in, and it handles all that automatically for you. But that's a lot slower than actually having enough RAM to load your programs up. Alright, so the more RAM you have, the better it is, especially if you're doing things which are quite data intensive. So if you're image processing, if you load up an image into an image processing software and you're manipulating the image and stuff, it has to load all that image data into the computer's RAM. So these days, if you take a photo on your phone, which is very high quality, the size could be 1 to 2 gigabytes of memory. So gigabyte is quite a lot of memory that it has to load up. All right, so obviously the more RAM you have, the bigger images you can process, and it means that you can run other things at the same time. Same with video editing. If you're editing video, that takes a lot of memory to be able to load video in and edit it and so on. Also for gaming, games are pretty huge these days in terms of all the data that they use and so on. So for gaming you need lots of RAM as well. So the more RAM you have, the better, obviously, but it also depends on your budget as to how much RAM you can actually afford. Okay, so that's what random access memory is, and the more of that you have, the better when you're looking to buy a laptop or a computer. Okay, let's go on to the next thing, which is the storage for your laptop or computer. So generally in the previous 10 years or so, The main form of storage has been the hard disk. So here's an image of a hard disk. So this is a complete hard disk here, and this is the inside of a hard disk. So basically a hard disk has spinning magnetic disks which hold the data. So if you look at the image of the insides of it, you can just see that there are multiple platters of disks inside the hard disk here. Alright, and what happens is the magnetic disks spin, and they spin a certain number of times per second. So some of the more common hard disks had about 5,000 RPM, or revolutions per minute. So it would do 5,000 total revolutions of a disk per minute. So that's pretty fast, right? Those disks are spinning very fast. Now, to access the data, the drive head moves up and down the disk. So there's the drive head here, and it moves up and down the disk. And as it moves up and down, it can read the data from the disk for you. And there's multiple heads inside between the platters of the disks here, so that it can read from any of the different platters on the disk. Now this has been pretty good before we had newer technology. The only problem was that these drives were slow compared to modern storage devices, because the disks need to spin, and it takes a certain amount of time for the disk to spin all the way around. And so as you're moving the head up and down, if you just miss your position, you have to wait for the disk to spin around and come back to be able to read the bit of data that you want. And it's also fragile. If you knock your hard drive while the disks are spinning and the head is moving around, you can cause severe damage to your hard drive. And if you cause severe damage to your hard drive, you can actually lose all that data pretty easily. So you have to be really careful that you don't knock your laptop or computer. You can just, a slight knock is okay, but if you drop it or something while it's using it, that can severely damage the hard disk. So these days, a lot of desktop computers may still come with a hard disk, but generally laptop computers, they don't have these hard disks anymore because they're quite bulky. They cause a lot of heat, which is a problem with laptops, and they're slow and fragile, which is not good for laptops either. So these days laptops have moved to what's called a solid state drive. So what is a solid state drive? So a solid state drive uses specialized memory chips similar to the memory chips that are in USB drives to store data for you. Alright, so these chips are different to the random access memory chips, because for the random access memory chips, when you turn the power off, you lose all the data that's stored on them, and then you have to reload all your data by restarting your computer. Whereas with these solid state drives, their chips are specialized in that they will retain the information even if you turn your computer off. Just like a USB drive, right? You pull your USB drive out, it's not connected to the power source of your computer anymore, but it still stores your data. So the earliest solid state drives were like these ones, which were kind of like a mini hard disk. They were in a kind of a little a package, and inside the package it had memory chips in it, which were the SSD chips, and you would plug that in. The only problem was that the computer didn't have direct access to the data because it has to go through the interface for this SSD. So it's still a lot better than these hard disks. They were a lot faster than the hard disks, but they still weren't, or they could be improved. So these days we have what are called M.2 NVMe drives. So don't worry too much about what NVMe drive means. The M.2 is important. The M.2 means it comes in a little RAM chip package. So it looks like a little RAM chip, and it plugs in directly into a proper M.2 port onto your motherboard. And these ones are faster even than these SSDs over here. So these ones are blisteringly fast. Okay, so they're so much more faster than a solid state drive, which is why all laptops use these, because they're a lot smaller as well. Look at the size of this RAM chip here compared to the size of this bulky hard disk over here. So it's a hell of a lot smaller, doesn't produce any heat or very little heat compared to the hard disk, and it's hugely faster as well. And also there are no moving parts in an SSD. Even this SSD over here, there's no moving parts, so it's a lot more durable. So if you happen to knock your laptop or your desktop computer while accessing the data on a solid state drive, it's you have a much less chance of actually destroying your data. The only downside is it's more expensive for the same size drive. Right, so if you have a 2 terabyte hard solid state drive and a 2 terabyte hard disk drive, then the hard disk is going to be quite a bit cheaper than the solid state drive. But then again, the benefits of the solid state drive quite outweigh maybe the price differential. So pretty much all laptops will come with SSDs. Most desktops will probably come with an SSD and also a hard disk to allow you to store bigger amounts of information rather than having to spend exorbitant amounts of money on huge numbers of solid state drives. So for desktop computers, they have a mix of SSDs and hard disks. So SSDs store your most frequently used applications and things, and the hard disk is used to store all your data like photos and videos and that kind of stuff. Alright, so that's the difference between the two main types of storage media, so hard disks and SSDs. So the next thing we want to look at is the screen resolution for your laptop. Doesn't really apply to a desktop because you'll have to buy your monitor separately, unless you buy an all-in-one desktop, I guess. In which case the screen resolution makes a difference. So the first thing you need to know is, how is your screen made up? So when you look at your screen, as you're doing now, you can't see the individual pixels that make up your image. So if we were to blow up a screen and look at this image here, this is what your screen would look like. It's made up of a series of little squares, and as you light the little squares or you don't light the little squares, it starts to make an image. So you can see for the letter A, we can make some of the little squares black and leave some of them white, and then by doing that in a particular pattern, we get the letter A and we get the letter B and we get the letter C as well. Right? So the more pixels you have, the better your image will look on your screen, because you don't see the the squares that make up the pixels that make up the image. If you have a very low resolution, the squares look really blocky and big. If you have a very high resolution, they're really minuscule and you can't actually see the actual squares, and so it means that your screen image looks really, really crisp. Okay, so that's what pixels are. And then your computer screen or your TV screen, applies to TVs as well, will have a certain number of pixels going across the horizontal direction, so the number of pixels going across and the number of pixels going down as well. So you probably heard some of these terms which describe screen resolution. So I've got another image here. So a common resolution for laptops is 1366 by 768. So what that means, there's 1366 or 1366 pixels going across and 768 pixels going down. So that is a reasonably low resolution these days. So generally the image wouldn't look as good for that particular resolution. It depends on your screen size. If you've got like a 10-inch screen, that resolution is going to look pretty good. If you have like a 17-inch screen, then that resolution is going to look pretty bad. And if you have a TV which is like 60 inches, that resolution will be awful to watch, right? So that's a common laptop screen size. The sweet spot for laptops and desktop computers is 1920 by 1080. So this is called 1080p or high definition. So it's 1920 pixels across and 1080 pixels down. Okay, so that gives us high definition. So anything which is HD will have 1920 by 1080 screen resolution. So again, if you have a 17-inch laptop with 1920 by 1080 resolution, that's going to look pretty good because you've got more pixels for your 17-inch screen. If you have a 10-inch laptop and you're using 1920 by 1080, then you don't need that high resolution because you're not going to make any difference for that size screen. So the higher the resolution, you need a bigger screen to make it worthwhile for it. Now you might have heard the term 2K resolution. So 2K resolution is this resolution here. So 2560 by 1440. So 2560 pixels across and 1440 pixels down, or 1440p. Okay, so that's 2K resolution. So obviously higher resolution is going to look better on a 17-inch screen. It'll look better on a 21-inch or a 31-inch screen as well. If you get up to screen sizes of about 40 to 50 inches, then you really need to go up to ultra high definition or 4K. So 4K ultra high definition is 3840 by 2160, so 3840 pixels across, 2160 pixels down. And then true 4K resolution is 4096 pixels across and 2160 pixels down. But you only need 4K for really large screens. If you got a 17-inch laptop, 4K resolution is just overkill for that. You don't need that size resolution. Okay, so unless you're going over about probably I'd say 27-inch screen, you don't need anything more than 1920 by 1080, so just normal high definition. In my opinion, you might prefer something different. That's up to you. If you're going between 27 to maybe 32 inches, then 2K is good, and probably anything above 32 inches you probably want to get into 4K resolution. Just remember, the higher the resolution, the more cost it is you're going to pay for your particular screen. Alright, so that's all of the different terms that you really need to be aware of. There's tons and tons of other stuff that we could look into, but you don't really need to worry too much about them if you're buying pre-built desktops or laptops. Alright, so hopefully you found the first part of this laptop BIOS guide useful, and then we're going to use that to help us in the second part, where we start to look at some models of laptops or desktop computers and see how would you know what things to pick out. Anyway, hopefully I'll catch you in the next video. If you like this video, please give it a thumbs up. If you didn't like it, you're welcome to give me a thumbs down. If you have any comments to make, or if there's any other things that you would like explained, then put them into the comments section, and then I can answer them as well. I'd really like to know. Anyway, that's it for this video. I will catch you in part 2. See you there.